So good evening everybody, myself Acharya Vishwendra. This is NCRT question discussions. So let's begin with chapter number 4, oscillatory motion and oscillations. So the first question is about projectile motion and examples of periodic motion. Then we have swinging, then oscillatory motion, then we have graphical variations of them, examples, periodic motions, equations, uniform circular motion, oscillatory and vibratory, simple harmonic motion, conditions for that, oscillatory motion, periodic or not. Then we have any material medium can be composed as, then collective oscillations, then examples of waves, then time period, then dimension formula, SI unit, quartz crystal, planet Mercury, Halley's comet, time period, dimensional formula, frequency, SI unit, hertz. Then we have calculations of frequency of oscillation of heart, time period, displacement can be defined, function as periodic and oscillatory, its time period. Then we have a numerical based on 3 different motions. Then we have a complex problem based on superposition of SHMs. Then again a numerical problem on that. Then time period, then some exponential function. Then conditions on the repetition or non-repetition of these functions. Then we have a standard equation of SHM. Then we have graphical variation of SHM in different cases. Then we have dimensional formula of amplitude, SI unit, the phase constant, dimensional formula of phase constant, SI unit. Then we have a graphical equation based on 3 different SHMs, their evaluations, functions. Then again we have a graphical equation based on 3 SHMs, calculation of time period, frequency, angular frequency, comparisons, etc. Then certain functions representing SHM. Then we have sine square omega t, sine cube omega t. Then we have a circular motion as a projection of SHM as a projection of circular motion. Different numericals are being given on that to find position, time related to the coordinates. Then we have 2 different particle system, the questions based on that, finding angular speed, direction, function as a time. Then we have the position, we are being given a numerical based on SHM. We need to find amplitude, initial position, angular frequency, time period, frequency, maximum speed, initial speed, instantaneous velocity, instantaneous acceleration, maximum acceleration, initial acceleration. Then we have concept of distance, average speed, average velocity. Then we have phase difference. Then we have a numerical problem based on SHM, finding mean position, maximum and minimum speed, conditions for maximum acceleration. Then we have a numerical problem based on SHM. We need to find initial position, angular frequency, time period, initial velocity, acceleration. Then distance traveled by particle. Then we have a graphical based question on that. Then we have time period, frequency, angular frequency, graphical variation between time period and mass, time period and root m, time period and spring constant, then time period and 1 by root k. Then we have resultant force in SHM. Then we have a spring mass system. We need to find its time period, frequency, angular frequency, equation, velocity. Particle executing SHM has. Then we have equation of SHM. We need to find the kinetic potential and total mechanical energy. Then we have to find angular frequency of velocity, acceleration, kinetic energy, potential energy, mechanical energy, time period of velocity, acceleration, kinetic energy, potential energy, mechanical energy, frequency of velocity, acceleration, kinetic energy, potential energy, mechanical energy. Then we have a numerical question based on SHM. We need to find its kinetic energy. Then graphical variation with position, graphical variation with x square. Then potential energy as a function of x, its graphical variation of mechanical energy with x. Then kinetic energy, maximum minimum conditions, potential energy, maximum energy, mechanical energy, maximum minimum conditions. Then we have linear harmonic oscillator, springness concerned with what inertia. Then we have a graph based question in which energies are plotted and we have to answer about the amplitude of oscillation, distance in one cycle, time period, frequency, angular frequency, position of P and Q, then mechanical energy initially. Then we again have a spring mass system and we have to calculate the resulting motion, time period, frequency, angular frequency, initial acceleration, initial force, amplitude of oscillation, maximum speed, maximum kinetic energy at certain position, maximum potential energy at certain position, maximum energy of particle, then instantaneous position, instantaneous velocity, instantaneous acceleration, absolutely pure simple harmonic motion, practical life, simple pendulum restoring force. Then we have for small angle oscillations, then we have angular frequency of simple pendulum, time period of simple pendulum. Then we have graph between time period of simple pendulum and length. We have a question based on the graph, then variation of t versus root n, then time period, then we have seconds pendulum, then its motion, damped oscillation, equations of that, angular velocity in that, and we have some graphical questions based on that. Then we have total mechanical energy, then we have mechanical energy of oscillator, energy time graph, small damping constant, SI units, AGS unit, dimension, spring constant, damping constant, time taken. Then we have free oscillations and forced oscillations. Then we have natural oscillation, then we have forced oscillation, amplitude and forced oscillation, maximum amplitude takes place at, then we have small damping amplitude, then we have resonance, conditions for resonance, then we have amplitudes, then we have concept of forced oscillation and resonance, then we have maximum amplitude condition, which is condition of resonance of a particular system, then earthquake, time period frequency graph, number of oscillation, hertz, graph between frequency and angular frequency, then a question based on SHM, we need to find amplitude of oscillation, velocity, acceleration, linear harmonic oscillation, non-linear, mechanical energy in real life, damping forces, angular frequency, time period repeats itself, circular motion with uniform speed, conditions at resonance, minimum number of conditions to determine motion, sum of SHM of given amplitude phase is determined by, and we have a question based on superposition of SHMs. Then we have time period of SHM, time period depends on motion, very small in amplitude. Then we have damped harmonic oscillation, then we have forced oscillation, then we have the condition for zero damping. So there are a total of 265 questions in this chapter, and they can help you in optimizing your time and energy in preparing NCERT in an object-oriented manner, which is the purpose behind creating these videos. Thank you and have a nice day.